Hi, friends. I'm going to be talking about the severe weather outbreak that's expected today in central Oklahoma up into southern Kansas. We have a high risk, level 5 out of 5, issued for these areas for what is expected to be a fairly significant tornado outbreak. The Storm Prediction Center issued this high risk this morning when details about the convective nature of the setup became a little bit clearer. They're expecting more favorable storm mode in this high risk region. But the severe weather risk goes all the way from far northern Texas into southern Nebraska as a generalized wide area of where this tornado threat is. Again, this is a tornado-driven threat. And I'm going to go through some of the details about what we can expect to see today, some of the forecast elements that tell us we expect to see supercells, isolated supercells, and tornadoes, but also a little discussion on potential failure modes, how this day could actually end up potentially not producing the highest ability that it could. Quick overview of the Storm Prediction Center's outlook today. Again, central Oklahoma into southern Kansas is your primary high-risk area, but that risk does extend into southern Nebraska and far northern Texas for where tornadoes are expected, and a little bit of a cold core setup up in the Dakotas here, and a marginal dry line risk along other areas. Again, in this primary risk area in the moderate and high, they are expecting isolated supercells with the ability to produce long track and potentially violent tornadoes. We're talking EF3, EF4 potential if the storm elements come together this afternoon. Here's a quick look at the satellite view this morning. Again, I'm recording this at about 10 o'clock Central Time, 10 a.m., and so we're just getting our first images of the day in for our broad satellite view over the entirety of North America. We have a upper level low, a very strong low pressure system centered here over far eastern Wyoming and western Nebraska. We can see this nice trough kind of wrapping around, bringing in dry and clear air up into the center of this low pressure system. And this low pressure is going to track northeast about into the Dakotas through the afternoon. This is a very deep low pressure system. In fact, it could verge on being a record low for the Dakotas for this time of year down in the 980 millibar range. But dynamically speaking, it's drawing up a lot of moisture from the Gulf of Mexico. We can see this northern motion in the clouds along the warm sector part of this. Dry air coming in, bringing in a dry line through West Texas and into far west Kansas and Nebraska. There are some interesting items to note in this particular satellite loop. I'm going to go ahead and zoom in here on Arizona and New Mexico, and again, this is to the west of our threat area, but you'll notice that there are a couple impulses coming across the mountains here. These are getting wrapped around the large-scale trough and out towards Oklahoma and your primary risk areas. And these are actually some shortwave elements that will be your primary trigger for the storms later today. I'll go ahead and turn on our surface station plots so we can see what's going on here. Again, we have good southerlies. We'll take a closer look at the actual tornadic environment in a second here. Strong southerlies and good dew points out ahead of the pressure system. But then we turn on the mid-levels, and if we zoom out a little bit again, we see this very large trough coming in. It's got a negative tilt to it, and I'll go ahead and demonstrate that negative tilt here. Here's our trough coming in, just like this. So basically, if you have a tilt to the right here, oriented southeast, northwest, that's a very strong negative tilt on this trough. Our low pressure, of course, is going to form on the leading edge of this trough and generally track to the northeast as the trough continues to swing through. Now, as the day progresses, we have these little kinks in the pressure lines at 500 millibars, and this is going to be our shortwave impulse coming across through the mid-levels and ejecting into Kansas, Oklahoma as the day progresses. Looking now at our surface map, Go ahead and look at the open warm sector here. This is the environment that's getting moved north into our high-risk area. We see rich dew points in the 70s, high 60s in southern Oklahoma, northern Texas. We have low 60s up in Kansas, but again, we expect these 70 dew points to move north. Another item to note is that a lot of these pressure barbs are actually coming from the southeast like this. So again, here to the northeast of Oklahoma City, we have southeasterly wind barbs. Further out to the west, we have southerly wind barbs that are a bit stronger, but all of that should bring in this rich moisture out of northern Texas and move it north into the area. These are almost easterly winds. I expect these to come a little bit south as the day progresses, but again, this is incredibly favorable for a tornadic environment just based off this surface map. Southeasterly backed winds, east-southeasterly backed winds, and strong dew points coming into the area. Observed soundings from this morning, and this is the sounding in Dallas, Texas this morning. So again, this is the environment that's getting moved north into Oklahoma and Kansas into that high risk zone. You'll see that we have very rich moisture in the lower part of this sounding. It's almost entirely saturated with 70s dew points all the way up to about 800 millibars. That's a very deep moisture layer. Again, if we go back to our satellite image, you can see that this deep moisture has caused cloud coverage over much of Texas, and that is going to move north. Back at this sounding, you'll see that, again, our moisture extends up to about 800 millibars, and then above 800 millibars, we have a little bit of a dry pocket. It looks like an EML, maybe not a completely mixed out EML, but it is creating a bit of a capping inversion. However, this capping inversion is not strong. If we warm our surface temperatures up to about 80, 85 degrees in this area, I think that we'll be able to overcome that cap very easily. And as we'll see in our forecast soundings going forward, that's going to create a large pocket of instability above that cap and easily breakable cap for any areas where our surface temperatures reach that higher temperature. Again, another thing to note here is our 0 to 1 shear is 28 knots. So this is our shear in the lowest kilometer, which is here from about 1,000 millibars to about 900 millibars. We have both directional shear and speed shear. Our lowest wind barb here is probably about 10 knots, and then we have 45 knots above that 1 kilometer, and this translates to about 28 knots of total bulk shear in this surface to 1 kilometer layer. That is a lot of shear, and it is only going to increase as we go throughout the day. And again, this will be lifted up into Oklahoma. Oklahoma shows a similar pattern this morning. The surface temperatures are a little bit colder, that moisture is a little bit shallower, but we do expect this environment to get moved north. Here's a look at our ensemble forecast from the HREF. I'm going to go ahead and start with the updraft helicity tracks, which is basically showing the mid-level rotation in storms, in convective storms, as they go through the day. Again, it is mid-level rotation. This is not necessarily indicative of tornado threat, but it is a good idea of where we could see supercells. As we track through the day, we'll see that we will have ongoing storms in southern Nebraska and northern Kansas with some rotational potential along this area. But then the real show gets started to the south, again, in far western Oklahoma and southwestern Kansas. These storms will fire up along a dry line and then generally move into the high-risk area as we approach evening hours. This is 0Z, which is going to translate to about 7 p.m., and we see that by about 7 p.m. Central Time, the storms will be approaching the I-35 corridor and then moving to the east, southeast through the evening. This is a very strong signal from the HREF probabilities here. We see that there's a 70 and even 90% probability of these rotating storms in these regions, and this is why the high risk is reflected here. Something interesting to note, though, about these helicity tracks, they do extend all the way into southern Nebraska. However, the ones down here in central Oklahoma and even southern Oklahoma are stronger helicity tracks. So if the storms are able to get going in this region, they're likely to be stronger or have the ability to rotate a little bit more. But there is still potential up into Kansas and southern Nebraska for this to happen as well. I'm going to go ahead and look at the dew point map here. So again, this morning, look at the current time about. We have our rich dew points down in far southern Oklahoma and northern Texas. As we go through the day, the 70s dew points advect north. So again, the moisture just gets deeper as we go through the evening and then reaches southern Kansas by about 7 p.m. in the evening. So the entire high-risk area will have really rich dew points as we go through the evening. Go ahead and take a look at the model forecast here. I'm going to start with the HRRR model to give a generalized look, but this is just one of the CAMs. Something to keep in mind when we're looking at convective allowing models, the CAMs, is that every single one of them is going to be wrong. This is a guess or an educated guess at what we think the atmosphere will look like in 3 hours, 6 hours, 12 hours. And it is wrong. The question is, how wrong is it? And are we able to parse out some details that can give us an idea of what will happen later in the day? Again, here's our look at that upper level trough. This is our 500 millibar mid-level winds. We can see that nice upper level low centered over Wyoming early this morning. That ejects northeastward into the Dakotas and brings this nice negatively tilted trough out into the plains. Something to note is that right now, Oklahoma and Texas are not in these strong high to mid-level winds. Right now, flow is relatively weak over this area, maxing at about 30 knots. As we go through the day, you'll see that this area of high and mid-level winds approaches. And as this area of higher winds approach in the high levels, it also increases lift, it increases shear, and overall synoptic support for storms to develop in these areas. You'll also notice, I'm going to point this out with the pencil here, that our streamlines are diverging. So these are these black pressure lines of equal pressure and ascent as we go east to west here. But if they're extending apart from each other like this, we'll see that the lines aren't totally parallel. They're kind of moving apart. This means that there's a broad region of upper level lift as out in front of this negatively tilted trough. So this means that the entire region is favorable for vertical motion as the ascent arrives, as these lines expand apart from each other. As we arrive, we'll see that the lines don't get quite as far apart, but then your high-level winds arrive and really increase the shear. So the combination of those two things, where we have our lines extending here and the arrival of the upper-level winds, that's going to be our main forcing. That's when the show starts, when those two things coincide. And you'll notice that the timing of these things coinciding is right at peak heating in western Oklahoma along a dry line. This is a perfect scenario for firing supercells across this region. We'll take a look at the surface thermodynamics now. I've been talking about dry line, but I'm going to go ahead and demonstrate that with our thermodynamic profiles. We have photographs plotted, centered on the X locations here, and then our colors are obviously surface-based CAPE. As we go through the day, we can see our dry line. The dry air is out here. There's a very sharp gradient of CAPE. Very, very deep surface-based CAPE profiles out here. Surface-based CAPE could reach 4,500 joules per kilogram or higher across central Oklahoma, where those 70s dew points are able to advect in. But even the mixed layer CAPE, the ML CAPE, is going to probably exceed 4,000 as we go through the day. So a very, very strong thermodynamic environment. So mid-afternoon, we expect storms to fire along the dry line, along the super intense CAPE gradient. And as we move through the afternoon into the evening hours, we'll see that the CAPE is getting etched out by cold pools that are being formed by the deep convection to the north. But still to the south, we have a very favorable environment that's being pushed up into the storms as they move east. This is a look at our CAP inversion. This is the EML that we demonstrated on the soundings a little bit earlier. Here in the morning, we can see that there is a bit of cap over the region, so we don't have any morning precipitation to speak of. Down here in Dallas, where we had that observed sounding, it's pretty weak. And as we go through the day, that cap basically disappears. So by about 19Z or 20Z, there is effectively no convective inhibition over any of the risk area. There's a little bit more in Kansas, but again, we expect the storms to fire out in western Kansas more so than eastern Kansas. So this area along the dry line is effectively uncapped. And out in the open warm sector, there is not a cap. In fact, we expect that it would be very easy to get storms to fire in this environment. Basically no cap whatsoever. One more look at our surface dew points, and I'm going to point out some features on the map. This is from the HRRR. The HRRR tends to underestimate dew points actually a little bit. So we see that this purple color here is your 70-degree contour. Dew points may actually be a little bit richer than 72 degrees, or than 70 degrees across Oklahoma through the afternoon. But what I really want to point out here is our dry line, very sharp dry line with the wind shift across it. We have southwesterlies to the west, we have southerlies, and maybe even some southeasterlies to the east of that dry line. There are some features to note, though, that there is a band here of very slightly higher dew points. This is convective contamination in the model output, but what is important to notice is that we have these southeasterly winds out ahead of this band and due southerly winds behind the band. What this results in is actually a little forcing band right in this area where we have southerly winds coming together like this, and your southeasterly winds doing this. And this actually creates a minor zone of lift in this right on the surface. This is a confluence band. It is not associated with a trough because there are no pressure falls with it. It is simply surface winds coming together. And if you have, I'll demonstrate on the side of the screen here, if you have wind at the surface coming together like this, your ground is here, that wind has to go somewhere. You're actually forcing that air up when your surface winds come together like this. So this is what this little band is doing. We're forcing air together, and we have a zone of confluence where we could actually trigger convection way out ahead of this dry line. This is not associated with dry line stuff. Let's take another look at this dew point map. Again, I find surface dew points and wind barbs to be one of the most important things to look at when parsing out a forecast. This is the HRRR. Again, dew point surface map. Your purple here, or your pink color, is the 70-degree dew point contour. And then I've added the reflectivity on top of that. Through the afternoon, we're going to see your dry line out here. We have ongoing convection in Kansas. And we notice that storms start firing off the dry line in the late afternoon and moving south through the Oklahoma City metro area into the high-risk zone through the evening hours. What I really want to point out here is that the HRRR is suggesting that we do see storms fire on that confluence zone I had mentioned before. Again, this is an uncapped environment, so there's really nothing preventing these storms from going. The HRRR does not form these into major supercells in central Oklahoma. It sends one off into Kansas, but again, the specifics aren't important here, that we do expect convective initiation out in the open warm sector in the mid-afternoon. And if this happens, because there's very little convective inhibition, I do expect that these can turn into fully mature supercells. Which means that for the Oklahoma City metro complex, you are potentially looking at, if your confluence band comes up, we have our main dry line group of storms here, but then we would likely see another group of storms out in front moving off to the east slowly. Now let's start talking about the specifics of the tornado threat. This is our 850 millibar winds, and with 850 millibar winds, we're going to see our low-level jet show. So here in the morning and into the early afternoon hours, it's relatively little low-level jet flow. there is enough here in the low levels to still create a tornado threat. Any storms that fire and become mature supercells in this environment today, even with the slightly weaker 30 to 35 knot flow in central Oklahoma, absolutely will have tornado risk. However, as we go into the evening hours, you'll see this low-level jet significantly ramps up. We're talking about the potential for 60 knots in the low levels into the evening hours, early evening, and then this is getting into late evening hours. And that effectively doubles the amount of low-level shear that we have, the amount of low-level helicity that we have out in front of these storms that are already ongoing. We fired the storms off the dry line, we fired the storms off that confluence band, and so any ongoing storms will have a significantly higher tornado risk into the evening hours. So let's take a look at our CAM solutions here. Again, all of these models are wrong, so the specifics of where an individual cell is are not important in this. I simply want to compare what the CAMs are doing with storm mode and where they are primarily firing storms. So this is going to be, I want to look at 19Z, right about when storms are going to be firing. Look at 21Z a little bit later. Okay. Here's the HRRR, what we already looked at. Again, it's firing some storms off of here. I do think these could be mature storms firing off the confluence band. And then we have storms firing off of the dry line in western Oklahoma. Most of the CAMs, if you look at this dry line area, most of the CAMs agree with positioning and timing of these storms. This is 21Z. This is mid-afternoon. We have ongoing mature supercells along the dry line. Again, some of the models are showing this confluence band, but not all of them. I do think that because of the uncapped environment, we will see storms out here as well. And most of the CAMs are in good agreement of the timing here. That's a great demonstration of that. Here's later in the evening. There will probably be ongoing convection out in front and your main dry line storms. We see that we've congealed into a more linear mass of storms, but there are still embedded ongoing supercells in this line of storms as they approach the Oklahoma City complex. So now the question of storm mode. How will these storms develop once they fire? And the most important element for this is the 0 to 6 kilometer shear vector. And we want this shear vector, the most ideal for isolated supercells is going to be 45 degrees offset from your forcing boundary. So let's take a look at this map and see if we can determine where that is going to be. We have our forcing boundary here, kind of demarcated by the rapid shift in shear values. This is going to be your dry line. Actually, it extends a little bit more like this up in Nebraska. This is going to be your dry line. We have a secondary confluence band out here, more or less demarcated by that. Our shear vectors, basically the average of all the shear through the bulk of the atmosphere, so 0 to 6 kilometers. We'll see that in Kansas, we actually do have that nice 45 degree offset. In Oklahoma, it's a little bit closer to 90 degrees, maybe call it 70 degrees. And then up into Nebraska, we have almost parallel and then almost perpendicular up in Nebraska and then almost parallel as you go into southern South Dakota. What this indicates to me is that CAMs are showing linear storm mode up here, but there could absolutely be supercells in this area simply based off of shear vectors. I think that confidence is a little bit lower, and I can demonstrate that in a bit, whether or not there will be supercells up here. But the shear vector is very favorable all the way along this forcing boundary. I would say that down here, because your shear vector is nearly perpendicular to your forcing boundary, that there's a greater probability for splitting supercells in this area, which would actually mean a messier complex. Basically, if your storm is moving due perpendicular to your forcing boundary, which is here, your dry line, you have the ability to send off left splits and right splits once the rotation gets going. But if your forcing boundary is here, and you have a nice 45 degree vector, this will favor, it'll still left split, but the left splits aren't going to be as dramatic or favorable, and your right splits are going to be strongly favored with a 45 degree shear vector. This means that if storm mode cooperates, that storms would actually be better for chasing up in northern Oklahoma and into southern Kansas, because your right splits will be more dominant, I expect that they could not be as messy in that they won't have as many mergers to deal with. And down here, we could certainly see very, very large supercells, but I expect this to grow into a complex of storms that is less likely to be photogenic, etc. Here's a look at our forecast sounding for the Oklahoma City area this evening. Something to note is that, number one, we get all the way up to about 80 degrees at the surface. Our dew points are, again, rich in the lower 70s. Just a massive thermodynamic environment. We have strong mid to high level flow, about 75 to 80 knots up in the higher levels. And then here we have very good veering of the winds. We have 50 knots just above 1 kilometer here. The hodograph shows strong low-level shear. In fact, the strongest element of your shear is 0 to 1 kilometers. That's where most of your shear is. This is streamwise vorticity, so it's going to be very favorable for ingesting that low-level vorticity up into the mesocyclonic rotation as we go. You will notice that our mid-level shear is a little bit lower, the element of our low-level shear. 3 to 6 kilometers, you're only looking at a maybe 10 to 20 knot difference in this area. And with this, plus our really rich dew points and deep moisture layer down at the surface, indicates to me that storms will be primarily high precipitation. Precipitation that's falling in the mid-levels of the storm will likely fall near, just ahead of where your primary low-level rotation is, and probably not interfere with tornadogenesis. You will still likely be able to form many strong tornadoes in this environment, but it will probably wrap around the backside of that circulation and create rain-wrapped high precipitation views as we go forward. Storm motion specifics. We will notice that in this sounding we have northeast, almost due northeast at 40 knots. That translates to about 50 miles an hour. A quick storm speed. This is pretty hard to keep up with if you're storm chasing, but it's not impossible. Again, our right mover storm vector down here is 40 knots. Left movers will be moving much more quickly at 60 knots. So any mergers that need to be watched will be moving much, much faster, almost 30 to 40 miles an hour faster than the right movers. Here's a look at our hodograph forecast as we go through the evening. Actually, this only goes out to about mid-afternoon, right when we're seeing the start of storms firing. We'll see that here in Kansas, we have storms have already fired by, what time is this, 21Z? And down in central Oklahoma, or western central Oklahoma, we'll see that storms are probably just beginning to fire. However, you'll notice that the hodographs in this area in western Oklahoma are pretty narrow in that there's a lot of shear, but not much SRH. Interestingly, that means that storms that fire out in front of the dryline storms will initially actually be more favorable for tornadoes. Shear is generally weak in this area as of yet. If we go to +6, you'll notice that the confluence band storms that are being suggested by the HRRR have about 40 knots, maybe 45 knots of effective shear. This is certainly enough to create supercells and certainly enough to create tornadoes. There's a greater shear vector out by the dryline storms, but again, if we go back to the hodograph map, the hodographs there are not quite as favorable for tornadoes because your low-level shear has not ramped up yet. So initially, I expect high visibility classic storm mode on the dryline storms, but they are not as likely to produce tornadoes. The confluence band storms will have higher low-level shear initially, but it just be in a generally weaker shear environment and probably be a messier storm mode. As we go through the evening, this will flip. The confluence band storms will likely move out of the greatest shear vectors, and the dryline storms will be moving into the sheared environment in central Oklahoma, especially as that low-level jet ramps up. If you have any questions about this forecast, please feel free to reach out to me on my social media. I will be tracking the conditions as we go through the day. I'll be tracking the forecast and any updates that come along. I will probably not be live tweeting. There's a lot of clutter on social media, a lot of people with their own thoughts. I appreciate you listening to mine. But if you have specific questions, reach out. I'm more than happy to track along things with you and talk about the specifics. So thanks for watching, and I'll see you in a future video. Okay, I'm going to talk specifically about storm chasing and the forecast for that today. I'm going to assume that you already know the details of the synoptic setup, already know the details of the high risk, etc. So I'm just going to start with the discussion about storm mode here. Again, I'm going to go ahead and point out our forcing boundary here, which is demarcated by the change in shear lines. This is going to be your dry line to the west. We have a secondary convergence zone, which is probably going to be a confluence band out in front here. So with this in mind, looking at the shear vectors, as we go into Kansas, you're looking at 45 degrees to the forcing boundary, all the way up to Nebraska. Here we have a slightly higher angle, so maybe 60 degrees or so, and then as you go south into northern Texas, this becomes almost perfectly perpendicular. Again, 0 to 6 shear vectors. So what this actually would say to me that purely on a shear vector standpoint, that Kansas and northern Oklahoma would actually be better for discrete storms. Or not necessarily better for discrete storms, but better for isolated storms as they come off of this area. Down here, this is certainly a favorable shear vector for supercells developing, but again, you'll probably see if this is our forcing boundary and we have a perfectly perpendicular shear vector to that forcing boundary, your storms that come off of this will probably have equal left splits and right splits as the mesocyclones get going. And so what this means, as multiple storms get going off of this boundary, that you'll see something like this and then a lot of destructive interference with all the storms except for the far southern one. So I expect that the far southern storm today, whether that ends up being in northern Texas or central Oklahoma, will probably be a very large right-moving supercell that will be able to maintain closed air. And then all of the storms to the north of that, because it'll be spitting off left splits like this, will become more blob-like. They will probably still be supercells given the shear vectors or given the shear profiles, but much messier. And then all of this in this southern area down here to the north of that southern isolated storm will probably congeal into a large mass with a single isolated supercell at the southern end of it. Further north, I'll go ahead and clear this and redraw our forcing here. Again, this is the dry line, and we have our confluence band out here. Further north, our 45-degree shear vector. I'll go ahead and draw this again with our 45-degree shear vector. This will favor a supercell moving off of your forcing boundary with a right mover going almost due east, a left mover coming off like this, but having a much harder time. This is probably going to be a smaller left mover and not have as much trouble with the other primary mode right movers that will come off this line. So actually in a more discrete mode as we go further north. Now, all of this is assuming is that our forcing is equal all the way across the board. Let me draw these shear vectors in one more time. We have a nice high shear vector there, and then one up here with our confluence band out in front. What I'm going to do is, oh, it's not going to let me click at the same time. Okay, go ahead and look at our upper level forcing, and we'll see that our forcing is actually much stronger up in Kansas. So even though the shear vectors are more favorable into Kansas and southern Nebraska, your forcing is much stronger, which means that you'll have more cells, more convection off of the dry line in this area. And you'll see that down here into Texas and central Oklahoma, the forcing is quite a bit weaker. Now, there is not any cap in this area. There's basically zero. Here we go. Here's our drawing again. Yeah, so we'll see that our forcing is strong in Kansas. It's weak down here. There's a little bit of cap that's hanging out up here in Kansas, but ultimately all of this dry line forcing and the confluence band forcing is going to be uncapped. So I fully expect that storms will develop in northern Texas, in southern Oklahoma. This is enough forcing to fire storms. They're probably going to be more isolated, and then again congeal into a blob as they come down here with supercells embedded. Up here, because the forcing is so strong, I think that we could actually see a more linear segments, or maybe even fire as a line and then break apart into distinct supercells as we come further east into Kansas. That's a tricky forecast to make. I think a lot of the cams have been hinting at a more linear mode up here. I'm going to assume that's caused by the stronger element of the forcing here. If we look at our href forecast, we can actually see the uncertainty in the helicity track forecast. Notice that the southernmost storm here is very strong in southern Oklahoma. I think it's possible we could see one in northern Texas based off of that forcing and no cap down in this area. However, most confidence in isolated supercells, again here in Oklahoma, but those are likely to have some interference, HP mode. And up here, we'll notice that the supercells aren't as long track, but there is an indication that we could absolutely see supercells in this region. They're likely to probably form as a line, split apart, congeal again, etc. But shear vectors are certainly favorable for supercells up here. So that's something to keep an eye on. Again, the highest confidence, highest probabilities are down here in Oklahoma. That totally makes sense based off of this forecast. But further north might be a sneaky play if you want to get out of the I-35 corridor with its awful high population, high chaser convergence, etc. Additionally, a secondary play would be to go south of the high-risk area into this moderate zone in southern Oklahoma, play the powerful supercell that will likely develop on this southern end. It's probably going to be HP. It's probably going to be more slow moving than the others in the area. So less photogenic, but also less traffic. Less problems with entering urban areas, fewer chasers down here because it's outside of the high risk zone. That doesn't mean that the environment is any less down here. In fact, your low-level jet is actually going to increase through the evening. If we look at our 850 millibar forecast as we get towards 0Z, your low-level jet is actually very strong down here in the evening, exceeding 50, possibly getting close to 60 knots in this southern area. It's just that the Storm Prediction Center is based off probabilistic, so it'll bullseye where the highest probabilities are, but that doesn't necessarily mean the environment is best in this exact area. The favorable environment extends everywhere where this low-level jet and the storms overlap, so down into far southern Oklahoma and northern Texas. So let's take a look at the forecast soundings here and our hodograph map so that we can get an idea of how these storms will behave once they've fired off of the dry line. I'll go ahead and use the 12Z HRRR. I think it has a pretty good idea of what the shear vectors are going to look like, and the thermodynamics are going to be so extreme today that subtle variations in dew points, etc., aren't going to have a significant implication on the forecast. So I'm going to stick with the HRRR here. We'll see that early in the afternoon, as storms start to get fired, we have elongated hodographs, low-level hodographs here in Oklahoma, and more linear-looking hodographs out on the dry line. And that theme is extended as we go into 20Z. Narrow corridor of favorable thermodynamics up in Kansas, broad corridor out here. Low-level shear is actually stronger out in central eastern Oklahoma. But if storms fire along this dry line, which we fully expect that they will, your mid-level shear is actually decently strong here. This is as that mid-level and high-level support is just starting to enter. And supercells could actually be classic mode, so higher visibility along the dry line when they initially fire. Towards 0Z, this is 7 p.m. in the evening. This is when our low-level jet reps up. We see that our hodographs are low-level, very elongated, out ahead of this storm clusters as they come through out in Oklahoma. This is when the significant tornado threat really ramps up. We're talking EF3, EF4 tornado potential. Let's take a forecast. Actually, I'm going to do a slightly broader aerial forecast sounding over the Oklahoma City metro area. Again, our low-level shear has increased. The hodograph has elongated. Our cap is basically gone. Low-level shear of 25 knots. 0 to 3 kilometer of 34 knots. This is more than favorable for strong tornadoes. Storm mode is certainly a question. I am not convinced that storm mode will be favorable for visibility in these areas. Again, because of this low mid-level shear, we're talking about a difference between 2 kilometers and 6 kilometers of about 15 knots in this area. I believe that this will mean that there's a lot of precipitation right out in front of where the mesocyclones are, and that the mesocyclones will have the ability to wrap that rain around. And this is all based off the depth of that moisture and the lack of mid-level shear here. This is a very favorable sounding for strong tornadoes, but unfortunately not a favorable sounding for high visibility strong tornadoes. It will be hard to get a look at those storms. So I'll go ahead and wrap it up here. If you are chasing today in Oklahoma, good luck, stay safe. I certainly hope that where the supercells develop, that they'll develop around the metro areas. This would be best case scenario for the day. Or our failure mode is potentially the confluence band fires too much convection and everything just goes slop, turns into linear bowing segments with little embedded circulations in them. There will almost certainly be tornadoes today. Best case scenario is that we would turn this into an MCS or just a cluster of high precipitation, flood producing supercells as they move across the region. And again, we hope that the supercells stay out of the Oklahoma City metro area. If we could get a few dominant supercells, maybe 3 in Oklahoma, 1 to go north, 1 to go south of the Oklahoma City metro area, that would be ideal. That would be better for chasers. That'd obviously be better for the people living in the metro area. Unfortunately, it does seem highly probable that at least 1 or 2 strong supercells will track through the metro area of the significant population center. And my recommendation would be to stay away. Stay away from the city. Stay away from the major metro areas as much as you can. If a storm is moving into the metro area, leave the storm. Drop south, drive north, do whatever you need to get out of the path of that storm. And stay out of the metro area. If you get caught in a hook, if you get caught in a core, or if you get caught in front of a rapidly developing violent tornado in a metro area, it's very difficult to maneuver out of the way, especially because the public is so in tune with this kind of forecast in the Oklahoma City metro area. Many other people will be on the roads. Some people will, unfortunately, instead of taking shelter, they will probably hit the roads and try to get out of the path, and this makes it very, very difficult conditions for chasing. So I would highly recommend avoid central Oklahoma. Even though this is probably where the most favorable parameters are, my recommendation, if I was out chasing today, I would either be playing on the Oklahoma-Kansas border here, or the southern mode south of Oklahoma City for that isolated supercell through the evening. So, best of luck. Best of luck. Have fun out there today. Stay safe. Obey the rules of the road. And I will talk to you later.